Greetings. Here you're looking at the innards of a Bally 8-ball pinball machine from 1977. This machine joined my stable recently. It worked when I bought it, but it's got some real ugly wiring work done to it. That needs to be fixed. So I don't know why, but these connectors, you can see one here. You got the wires coming off of the harness, going into the connector and plugging into the board. Now this is the MPU board, and for some reason they soldered a bunch of wires to the pins. Those go to a DB25 connector, and then the original harness wires were soldered to the other end of the DB25 connector. Now normally when people do this, it's usually much sloppier because they'll leave out the connector and they'll directly solder these wires to the pins over here. And yeah, that'll make it work, but then you can't remove the board because it's hardwired into the machine. So at least they had the decency to put a connector here, so if you disconnect this, you can remove the board for service or for whatever. However, this doesn't fly for my machines. So what we're going to do today is bring it back to, as much as possible, to its original state. Basically putting a connector shell like this on the original wires, replacing these header pins over here, which are kind of rendered useless because if you solder them, you can remove the solder, but the connectivity of them is never as good as it was before they were soldered. And then see, of course, if the machine still powers up. So for reference, since this works, let me show you what the machine does when you turn it on. It runs a self-diagnostic or a post, and this LED should blink 7 times, which it did the last time I tried it, but that's the if we rewire this and then turn it on, that's what should happen, rather than smoke coming out or weird noises. So I'm switching on the power now. Okay, it blinked 7 times, played the startup tune, and if I look at it, the displays are up, everything works. So the last question is, of course, why change this? Which I think I kind of answered. I mean, you shouldn't do things like this. Put the machine back in its original state. Yes, it's going to be a bit of a pain, but it's worth it. So first we ohm out all the connections from here to the actual pin. And note the wire colors, because these are basically going to connect directly to here, and we're still going to use the technical manual to double check everything, but at least we'll have a list of how things were connected when it still worked. And for reference, here's a view of my other machines that have that connector unmolested, and this is what it's supposed to look like. So we have a reference, so I can check the wire colors against this because they use the same wire colors. Machines are pretty close in age, and the wire colors are the same. But on top of that, I'm going to use the manual, which also lists the wire colors and tells, what wire color goes to which pin. First we have to find a connector shell, and I took out whatever I had, and I don't have the right size. I may have one in here, But I don't want to use these connectors where you crimp the wire into the connector itself, but rather a shell like this, and you put pins inside. You crimp the wire to the pin and then you slide it inside. But yeah, I could probably use a couple of them to make up a 19-pin connector, but what I did find is this. This was like a 22-pin connector. I cut it down to 19, and I put a blind plug right here, and that's used to key the connector. Because when keyed properly, the male part will have that pin cut out on the CPU board, and you can't fit the connector in wrong unless you're really strong. So now that we have the shell, let's look at how we're going to crimp pins onto wires, which we're going to have to do to all the wires that are now badly connected. What do we need? We need the shell, of course, which we have. This wire is a representative of the wires we're going to insert into this. Those wires that are going into that are coming off the original harness and going into the DB25. We need connector pins, which are conveniently mounted on this metal strip. Most likely they have like the $3,000 crimper at the factory that cuts it off here and everything. I don't have that, so I'm going to have to use the cheaper removal tool here. Go away. And basically grab the contact and wiggle it off. So now here's the contact. Then we have our crimping tool, and we put the contact into the smallest slot it has, which is this one right here, and it doesn't want to go in because those contacts are splayed too much. So let's gently push them together, just a little bit. What we do then is insert them inside of the crimping tool, like this. Then we take our representative wire and slide it into the U-shaped slot as far as it'll go, and then we press the crimper with all our might, and there it is. If you do this properly, there's no soldering required. We do a test. Great, I bent this. Anyway, is it still tightly in there? And it is. And then all we need to do is take the connector and insert the pin from the right side into the proper slot we want. It clicks into place and it's in there, and we got an original connection. So I'm going to go ahead and do that now to all of the wires you just saw, and then we'll continue. Now that was fiddly, very much so, but it looks good. Everything is in the right place. I double-checked wire colors. I double-checked it against the other machine and the service manual. So now it's time to take out the CPU board and basically go in replace, get rid of this mess over here, and put new header pins in there. And while I'm at it, put a button cell in instead of that battery. Patience on the operating table. So we're going to start removing this mess. One interesting thing to note is, see a lot of copper showing right here, which means whatever battery was in here was an iCAD rechargeable and it leaked. And it traveled all the way over here. And the reason the copper is showing, this was repaired. Somebody sanded this to get rid of the battery damage. I don't know if you can read that, but it was repaired by Pintronics in Canton, Massachusetts. There is no date on the repair. I can also see that there has been some, there's copper showing here that they covered up with their stickers. So yeah, and here it got, they're soldering, there's still some damage over here. But they fixed it and they left the useful message updated to use lithium battery R12 replaced with diode. So the reason they did that is so the board doesn't try to recharge the battery. And before replacing the battery, I figured, hey, let's see what the battery says. Can you see that? No, not at all. Stay. Can you see that? Yeah, you can kind of see that. So let me measure the battery. And at the battery terminals, it shows 3.68 volts, which is, it's a 3.6 volt battery. We have no clue as to when this was replaced, but if the battery is still holding near, not near, but it's holding the stated voltage, the battery is still good, and I see no reason to replace it. And yeah, I don't want to see a comment that says you're an idiot, replace the battery. I won't, because this battery is still good and will be for a while, and I'm not going to throw it into the landfill because it's still good. So let's go ahead and do some desoldering here, and replace the pin headers. Now look at how nicely that pin connector cleaned up. Looks almost new, doesn't it? Nah. Here's the original. It was not savable. And as I said, once you put solder on the pins, they seem to lose connectivity. So, or, you know, what you're doing is you're basically putting resistors in series with every pin by doing that, and you will have some really strange results. But the good news is we got all these free parts now. We got DB25. Let's see, did they glue this together? I'm trying to take it apart. Oh, there you go. No, see, I got perfectly good pair of DB25 connectors, and maybe one day when I have a free afternoon I'll try to clean this up. But yeah, it looks like the board's done, and the time has come to put it back in the machine and see what happens. Alright, the board's back in. Oh, I don't even know if I put the proper key on this thing, but it looks like I did. So I'll point out the diagnostic LED again, which is here. So, well, let the sparks fly. 3, 2, 1, go. 2, 3, 4, 5, 6, 7. Woohoo! It passed. Well, let me clean up a little bit and we'll play the obligatory game. Well, here she is. The 8-ball from 1977, showing I think an unlicensed likeness of the fawns on the back glass, on the side art. But I guess in those years nobody really cared about it. Playfield's pretty nice. This, I mean, the machine is what, 45 years old. And I think the reason the playfield still looks as nice is it was played for a while, but then I think it was clear coated. Because you see some wear, but then they just clear coated it and preserved the wear forever, but it's in pretty good shape. And a few fun facts about this machine. This machine sold, like just a few hundred over 20,000 units, which was an absolute record at the time. And then in '91, I think the Addams Family Pinball came out, and that sold about the same amount. But they did, in addition to the regular run, they did a limited edition gold collector's version of the Addams Family of 1,000 units, which sold out immediately and catapulted the Addams Family into the #1 spot because it sold over 23,000 units. And I believe that record has not been broken. All right, here goes nothing. Oh, and another one, another interesting fact is that since it's an early solid-state machine and it did not have an electronic soundboard, you probably heard the chimes already. Those didn't come until later, I think 78 or so. The chimes in this machine needed a little bit of service, but a few grommets will probably bring them back to as new condition. Off we go. Very simple layout, but it's a fun machine to play. You don't need a PhD to figure out how to play this one, which isn't true for a lot of the newer machines. Ooh. Well, thanks for watching. I would really appreciate a thumbs up, comments, subscription, hit the bell, and all that good stuff. And we'll see you in our next adventure.